I'll try in 45 minutes to show you the whole process of a service, from a commit to production until from a commit to repository all the way until it's in production. Right? We'll be using Docker, we'll be using Jenkins, and quite a few other things. It will be very intense, so prepared. So this is me. My name is Viktor. I work for a company called CloudBees. Short version of what we do is that we are a company who does Jenkins. I'm also one of the Docker captains, so I'm very interested in both containers and continuous integration, continuous delivery. Write blog, do some courses online, YouTube videos, books, buy them now. So as I said, it will be very intense. I'm going to try to show you the whole picture, not to teach you about some details. Later on, we can speak about things after the session if you have any questions and things that I did not cover. So let's start with theory. I'm going to do most of the presentation will be demo. I like hands-on parts, not speaking too much. Nevertheless, I'm going to just mention quickly. So what we are all moving towards microservices. We are all starting to dismantle all those monoliths, realizing how awful they are. That's nothing new. You already heard that many times before. Everybody talks about it for 5 years. The real question is, why are we doing microservices now, right? It's not anything new. Microservices exist for like at least 20 years, right? Linux, Unix, that's microservices. Small programs combined together to provide certain complex operations, right? So the reason why we are interested in microservices the last couple of years a lot, because many of the things changed. Infrastructure is slowly moving towards, or at least part of infrastructure as services is moved towards containers. Containers allow us to remove many of the problems we had in microservices yesterday, before, like dependencies, infrastructure madness, and all those things. And everything becomes immutable. You will see soon my cluster is immutable. I would never update any of the servers. My deployments are immutable. Everything is immutable. Everything is an image. And that gives me a high level of reliability because I know that everything that runs on my laptop is the same as it runs on test environment, production environment, and all those things, right? In other words, that means whomever of you is using Chef Puppet Ansible, throw it to trash. That's the short version of it. So consequences of all those things, once we adopt containers, continuous deployment, clusters, etc., our service finally can be a cluster, right? When I say a cluster, I mean it's a single entity when you treat all those servers as a single entity and as a huge computer, right? With, I don't know, 578 CPU and stuff like that. If you name your clusters, your servers, if you put them names, if you decide where you're going to deploy your application and do things like that, you're not having a cluster. Doesn't matter if you have 1,000 servers or 2, that's not a cluster. A cluster is when you treat everything as a single entity. You will see soon. The result is that you need to change. It's very likely that many of you will need to change your architecture of your application, of your services, because it needs to be really designed to be distributed, to be cloud-friendly, to be container-friendly, and all those things, which are more or less the same all the time. It will have to become immutable. It will have to become stateless. That does not mean that there is no state. There is, but not in your service, somewhere else. And finally, you will need to adopt service discovery. That means that your property files, configuration files, and all those things where you put, this is the IP of my database and things like that, will need to go to trash because you will not know where your database is and other services, right? So they will need to discover each other somewhere within a cluster. So we need new processes. Everybody is already agile. Most of you are faking that you're agile, but that's still okay. One of the problems with Agile is that it excluded operations. It excluded second half of the processes, usually, in most cases, right? Though there were still, Agile teams are having a party and QA and developers and stuff like that, and an operator still sitting in some basement eating chips and waiting for your Jira tickets. So DevOps tries to change that. It's kind of evolution of those processes. It includes operations, operational knowledge, and a few other things into those same small teams. When I say teams, I mean like 8 people, right? 20 people, that's not a team, that's just madness. Working on the same project, same service or application. Result of all that is that if you want to adopt Agile, you will be, DevOps, you will be, finally your teams will be in full control, meaning that this is my service and everything related to that service is me, my team, right? Those 8 people. There is no other person to call at 7 o'clock in the morning and things like that when things fail. Everything is in control of a single team. That's where we are going. That's what microservices are about, having small teams that are fully capable of executing whole project, whole service, whole application, and doing everything related to it. And what that all means is that it doesn't matter whether you're specialized in development or testing or operations, you need to understand the whole process. You need to understand everything going on, otherwise whatever you're doing is going to suck. Simply because, like, if you're not testing, you don't know how to code your application. It is testable. If you're not deploying, you don't know how to code your application. It is deployable, and so on and so forth. And then you end up with those horrible situations when you need to open a Jira ticket. So you need to really understand the whole process, have hands-on practice on the whole process, and only that you specialize into something. So I'm going to focus today, among other things, mostly on Docker and a bit of Jenkins. Who is not using Docker? Brilliant. Everybody's using it. It was a trick question. Okay, so you know what Docker is, right? You know that it's portable. You know that it has very low usage of resources. It's scalable. Everything needs to be scalable today. When I see you have one instance of an application, I mean, you must be living in 1999 because it's just silly. You need to have applications that are scalable, otherwise they're not fault tolerant, they don't have high availability and all those things. Isolation of processes. Since everybody says that, nobody said that you don't know what Docker is, so no need to speak about Docker. We're gonna go into demo. You know that, just quickly, Docker has quite a big ecosystem, right? I'm not gonna use all of the software that comes out of it, but focus on a few of the things. And one of the things that I will not do from this presentation, but you can do yourself, is to create a cluster. And the reason why I didn't do that is because it takes approximately 10 minutes, and I don't have that much time to spend only one thing. So I created my cluster myself. If you want to replicate that, there is a video, so just follow the video. You will have exactly the same cluster as I created. A quick note is that I use Docker for AWS. It's CloudFormation template. You execute a command and wait for 10 minutes, and you have a cluster. In this case, I have 3 nodes. That's more than enough for this demo. And the cluster looks more or less like this. I have some managers. Normally, I would have workers, but I was cheap today. Managers, workers, you host containers everywhere, load balancer at the top so that requests are always coming to a healthy node. There is a proxy inside. And finally, cluster registry where Docker for AWS keeps information about where is my manager if I want to join another node into the cluster. And finally, of course, EFS. We need external file system, otherwise persistent of stateful services would simply not be possible. So let's start with the demo. I'm connected through my mobile because Wi-Fi here does not want to work with AWS. Don't ask me why. So if it breaks in the middle, it's not my fault. So here you see that I have, this is my terminal, and I will actually show you very quickly. This is how my cluster looks right now. It has 3 nodes. And it's almost empty. The only thing that I have is visualizer, which is this thingy here, which shows you how a cluster looks like. I have one swarm listener, which listens to events and configures everything inside of the cluster automatically whenever a service is deployed. And I have a proxy that will forward requests to the services, right? Apart from that, it's only almost empty. So let's see. So I'm going to go in the middle of the process first, and then I'm going to go at the beginning, at the commit. But middle of the process means I need to deploy my service for the first time. And I'm going to do that by downloading something called Stack. And I'm going to show you how it looks like. This is a very simple stack that defines my services. It's in YAML file, It says, okay, there are two services. One is called main. Interesting thing about this service is that it has an environment variable db set to value db. So this service does not use configuration property file or anything like that. It uses this environment variable to communicate with the database, and it will assume that automatically the system will find where the database called db is and forward all the requests, right? So I will never, ever, 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 ever specify IP of the database, right? It belongs to a couple of software-defined networks because that's how services communicate with each other when they're spread across the cluster. I will want immediately to deploy 3 replicas of this service because for fault tolerance, high availability, you always deploy multiple. Remember this, I will show you later why. Just remember that I said that I want update to have parallelism set to 1 and delay of 10 seconds. You will see later on just why. Just remember that those two things exist. And labels. Service labels are very important because basically what the concept behind running schedulers is highly dependent on that, is that you're not, if you have some other part of the system that needs to know information about this service, you don't configure that part of the system. You give all the information within the service, and then other parts of the system are supposed to read that. So everything is decentralized, right? And in this case, I'm telling that I expect my proxy to configure itself with /demo as path of this service and internally running on port 8080. And I expect proxy to be intelligent enough to be able to read automatically these labels and auto-configure once I deploy the service. We're going to see whether that works really, but. And the second service is database. It's a MongoDB. That's the one that I'm referencing here with the environment variable. If you have questions, you can stop me at any moment. So to deploy those services, okay. To deploy the services, I just execute docker stack deploy, give it the name of the file, YAML file. You don't see this, right? You should complain. Do you see it now? Yeah. Okay. So docker stack deploy, give it the name of the file, and give name of the stack, some name of the stack. And this file is what I just showed you, this YAML file, right? I'm deploying, and that's it, right? I already have 2 services up and running, one of them 3 replicas, and the other one is a database which I did not bother to replicate. And we can confirm that by saying docker stack ps, which gives us, remember I'm going through my mobile very slow, which gives me information about services in this stack, and you see that they are all starting or running. You see that they're starting, running, starting. Soon they will all start, and they're all running. So those services are already running in my cluster. It was very easy and distributed, right? At no given moment, I'm saying deploy there, right? Schedulers, in this case, Docker Swarm is deciding where to run. If you like pretty colors, you can see that my cluster already got populated with those services, those 2 services. Okay, so now the service that I run is something we call replicated service, meaning that we specify how many replicas we want, and they're spread across the cluster. Now there is another type of service I'm going to create without the stack now, Docker service create. I'm going to call it util because this will be utility service we're going to use soon. I want to show you how networking works. So I'm going to attach this service to the network called proxy. I'm going to attach it also to the second network that was created out of the box called default. I'm going to say that it's global. What that means is that it will be on every single node of the cluster, no matter how many nodes we have. So I have 3 nodes, there will be 3 replicas of this service. If I would have 1,000 nodes, there will be 1,000 replicas. Simply, it would run absolutely everywhere. I'm going to run Alpine, which is very very thin operating system-ish thingy, just a few megabytes, and I'm going to let it sleep for a very long time. And the reason for sleep is because if I just run Alpine, it would there would be no process inside. It would stop immediately, and then Swarm would reschedule it, and then it would enter into a loop of failure and reschedulement. So I'm going to let it sleep so that it doesn't fail. Let's take a look. If you look at the services, you will see process of the service. Since we said it's global, it's running on every 3 replicas because there are 3 nodes in a cluster, and so on and so forth. So I'm going to execute this command. It's not really important. The only thing I'm doing now is to get the ID of the running containers from this host so that I can enter inside and show you how networking works. So if I say I'm going, and the reason why I actually created this util service is because I need something called drill. Drill is anybody using drill? No idea. Anyway, drill gives you DNS information about DNS information, right? It will give me for each DNS information what it is, where it is, and so on and so forth. Now, the reason why I need container for that is because the operating system I'm using right now does not allow me to install anything. It's physically, I cannot install, I cannot use apt-get yum or anything like that. So everything, absolutely everything needs to be a container. So in this case, since I need a utility, I need drill, I'm going to enter into one of the containers and install it. I'm going to say add, update yourself with something called drill. So this is happening now inside of this container. Actually, even SSH that you're seeing right now does not exist on operating system. Even SSH is inside of container. Absolutely everything. It's highly optimized for Docker containers. So I'm going to show you how networking works. So I'm inside of util container. Remember that it's attached to the network proxy and the other one. And if I say drill, show me the information about a service called godemo2db. You see that there is, it responds. The service gave me response, and actually it works on, it got assigned this IP in case you need it. You don't basically, but just in case you need it, that's to see that's the IP, internal IP of the service. And the other service, if I drill it, if tethering works, no, not main. The other service is also accessible through its name. All you need to know is the name of the service. It's just that this time it got a different IP. And if you note, and one thing important to understand is that networking not only gives you service discovery, it gives you also load balancing. So when I send a request to a service that has 3 replicas like this one, that request is load balanced across and sent to one of the replicas. And this is IP of the service itself. If you want to get IP of each individual replica, then you can just prefix this with tasks. And you see now that the service called main has 3 replicas with 3 IPs for each one of them. So enough of that. Let's see. Sooner or later, before I start to go into continuous deployment and things like that, sooner or later we will need to scale our service. Scaling not very often, but it should mean that there is a monitoring system that collects your metrics, that monitors, let's say, your response times, and if response time is slower than X, it would go and scale your service so that actually it can respond within your SLA and scale down if response is too fast, right, within certain limits. So how that alert would do the scaling is with a simple command, docker service scale, and I want to scale service called godemo2_main, and I want to have 10 replicas, right? And if I go back to this thingy, you will see that number of replicas already increased, 10 replicas. The service was scaled, right? And then can handle the imaginary increased traffic without any problem. And I can confirm that docker stack ps desired state equals running, and the name of the service is godemo2. the name of the stack actually is code demo 2. I'm sorry, but this is just terribly slow. Maybe. Go. Yeah, and you see that there are 10 replicas already up and running inside of my cluster. Okay, so now we're going a bit backward. I already showed you how to deploy a new service. But before we deploy a new service, we need to build an image that will be transformed into those containers later on, right? Now, before I build the image, actually now we're more or less at the beginning. Let's imagine that somebody did a commit to repository, and we are still not having Jenkins. We're doing things manually because we are just masochists. So the first thing I need to do is to check out code from Git, right? Everybody's using Git, nobody's in SVN, hopefully. Anyway, and since, as I said before, there is no Git on this operating system. There is nothing, right? I need to run a container, and in this case, I'm going to run Git in a container and say, within that container, clone this repository. And since I'm using volumes means that a directory, in this case pwd, meaning current directory, will be mounted as a certain directory inside of this container, so that whatever is done in that directory in the container will be available on the host, and I will get my files. So I'm downloading Git container already pulled up and running, and I cloned my code, and we can go there and see, confirm, my code is cloned. So this is what first step after the developer does the commit, right? So let's look at the Docker file. So Docker file defines, for those of you who faked that you know Docker, Docker file defines how an image should be built, what should be inside it, right? But this one is a bit special because it uses some features that are only a few months available. It has actually equivalent of 2 Docker files in single Docker file. So what is happening here is that this, by the way, this service is called in Go. So I'm saying, give me an image of Go, because I need to build it and run tests and do some stuff, right? And then add all the source code to the directory src, download all Go dependencies, run all my unit tests, and build a binary. And then, now if this would all be all together in the same stage, this would result in a huge image, because Go is a huge image, and having builders and dependencies inside, that's just horrible. So in this case, I'm using multi-stage builds, meaning that once this is finished, destroy this completely, remove. I already tested it. I built my binaries. I did everything. I don't need you anymore. I want to start from scratch. And I'm going to use Alpine. I'm going to define that port 8080 should be exposed. I have that environment variable that I showed you before. I'm defining that future container should run Go demo binary when it starts. A health check, meaning that run health check every 10 seconds and run this command. Doesn't matter what command is, as long as it returns 0, it is healthy. Anything else would mean it's unhealthy, and the replica should be destroyed and started again, right? So you have that incorporated, and this is now the new part. I say copy whatever was done here, copy it into this new image in this directory, and give execute permissions. Health check, define new, 1 year. So what is important, so health check has more than two, but 2 primary functions. One is that if it's unhealthy, depending on your strategy, Swarm will destroy and start again. But more importantly, if it's until it is unhealthy, it will not receive requests. So if I have 3 replicas and one of them is unhealthy, requests will be load balanced across only those 2 healthy replicas. And that is very important during upgrades, sorry, not upgrades, releases and rolling updates.
Excuse me,
sure.
How does one container expose itself as unhealthy?
Because you see this CMD?
Yeah.
whatever comes after is whatever you want. Docker does not care.
But what I mean, as the process running, what does it do to report that it's unhealthy?
You see, I mean, the major purpose is to report to Docker Swarm, not to you, if that's what you mean.
Yes, okay.
Yeah, you're not supposed to. That's one of the things. People like looking at dashboards and reports and stuff like that. Why? Kind of Netflix is like $7 a month. Watch Netflix. Don't watch reports of health. Because all those things should be done automatically. If it's unhealthy, do something, right? But yes, I'm going to show you. If I can show you the health of services. If you want to manually see whether it's healthy or unhealthy, that can be done. I can show you.
No, I didn't want to see it manually. I was just curious to who would that container report.
It reports to Docker Engine, and Docker Engine then uses that information to decide whether requests should be sent to that service and whether potentially that replica should be restarted. Okay, so let me build the image. So I'm going to say Docker image build. I'm going to give it a name. Since I'm using Docker Hub public repo, I'm going to prefix it with my username. I'm going to call it Go Demo 2. And last argument is always the directory where Docker file is, and dot means current directory, so I'm building it. I have my image. I will have my image soon. Actually, right now I'm having nothing. It's downloading Go. You can see here. And so this is not building images actually only. It's half of the process, because now it's downloading my libraries required for this service. And now it's running my tests. So I would never build it. It's just silly to build your binaries without running tests. It's waste of time. And you can see actually here that all my tests are executed. They all passed. And since they passed, I can proceed. And it built my binary. And after that, it started from the scratch again and created a new image, which is basically there. So let's, I need to have that image. Maybe. I need to have that image in my Docker Hub account. Otherwise, I could not use it in other servers of the cluster. So I'm going to log in to my account. OK, and I'm going to say Docker image. I'm going to push it to push the image that I built previously. And the tag is latest. If you don't specify tag, it's always latest. I'm going to also tag it. I'll always tag twice. I always tag latest because for people who want latest tag, but I tend to also tag it with a specific build number. So we're going to say I want to tag Farcic Go Demo 2 as Farcic Go Demo 2 release 2.0. It's already the second release, and I'm going to push that. 2.0. OK, so I have my same release as 2 tags in my Docker Hub. And now I should update, right? I made the second release. And at the moment in production I have first, I should update my production. Now what I'm going to do is execute the rolling updates. What that means is that since I expect that potentially this service could be deployed to production every 5 minutes, right? There is no restriction how often, because every commit is supposed to go to production. And prerequisite for something like that to work is that there is no downtime, right? Deploying every 5 minutes or every hour or every day with producing downtime, even a second, just stupid, silly. So I'm going to do rolling updates, and what that means is that I have 3 replicas, and the Docker will update one at a time. So I will have 2 replicas, and then 2 replicas with 1 replica on with the new release, and then the second will replace and stuff like that. So Docker Docker service update. So I can update any aspect of the service, anything the service has. And in this case, I'm going to say I want to change the image. I want to use the one that I just built, and it's release 2.0. And the name of the service that I'm updating, if my internet works, yes. Okay, and so I'm updating a service called godemo2_main. And now I need to be quick to show you how this looks. So this is how my services look like, and you will see that I have 10 replicas. It's very hard on this screen, but you see that one of them is changed to 2.0, right? And then, since I said that I want to have a delay of 10 seconds between updates, that means the Docker will wait for 10 seconds. And then it will wait for 10 seconds more because I said that I want health check every 10 seconds. So it will wait until the first health check reports that everything is okay. So that's approximately 20 seconds between updating each of the replicas. Since I have 10 of them, it will take a while. There's no need for you to watch all that. No, what's going on? Okay. But you see that a few of them are already on 2.0, and the process will continue, right? So now that I did all that, right, let me go back to presentation. You saw how to deploy a new service. You saw how to update service. You saw how to build images. And you saw how to build them with including tests and all those things without making image big. Because this service that I just built, if you look at the size, you will see that GoDemo2 is like 20 megabytes. That's partly because it's Go, which is slim, but still, I have no overhead. I have very minimal operating system and all those things. So, okay. So now that you have rough idea about how part of the process of continuous deployment, of what we should do when on every commit, I'm gonna just switch into Jenkins and do the same similar thing automatically. So Jenkins, who's not using Jenkins? Who doesn't know what Jenkins? Everybody knows what Jenkins is. Who doesn't know? You know. Okay. No? Okay. Excellent. Brilliant. Then no need to spend much time with it. Continuous integration, continuous delivery, continuous deployment, does everything, cooks coffee, orchestrates stuff. It's awesome, and all those things. That was marketing effort from me. So let's see how do I do continuous deployment. Before I do continuous deployment with Jenkins, I need to create Jenkins service. I need to deploy Jenkins stack. So I'm going to download. Okay. Wrong directory. Okay, so I'm going to download the stack, and I'm going to quickly show you this stack because it's still slightly bit different than what you saw before because it has some new features. I mean, it's not new features, but things I didn't show you. So this is, again, I'm running Jenkins. I'm running my own Jenkins, which is customized for these purposes. Try to run your own images when you need to customize something. Don't do manually anything. Not important. This is new. I mean, new in this session. Since Jenkins is a stateful service, right? Unlike a GoDemo service that is stateless, this one has state, and Jenkins state are files. And that means that I need to persist those files somewhere else, somewhere that is not on this server. And we do that by using volumes. So there is a volume called JM, and it mounts to Jenkins home. The second one is not important. I'm going to show you what JM is soon. And yes?
The volumes were among, I mean, in the host, or this is
3 seconds. Give me 3 seconds. I'm getting there. Okay. I'm getting there. A few labels so that they are configured through the proxy. This is new. I'm telling that I want Jenkins to use 500 megabytes. So that Swarm knows that it should deploy it not to any of the servers, but wherever there is so much megabytes available. If it reaches 1 gigabyte, means that I'm doing something really ridiculous and stupid. Maybe there is a memory leak, something. It should be shut down, killed, destroyed. and one Docker agent. Now, the important thing, where is it? Let me see, did I miss it? No, okay, it's in agent. Yeah, here, actually. I want this Jenkins to be protected, right? And it needs to have a username, it needs to have a password. It's not kind of anybody can enter it. And the best way to supply that is through Docker secrets. Docker secrets means that there will be files somewhere inside of container. They will be in memory, meaning that if container goes down, it will disappear, no trace of it. So in other words, there will be two files, one with Jenkins user, one with Jenkins password that will be available to Jenkins and nobody outside. And the same thing for Jenkins agents, where I'm going to run builds. It has those secrets. It even has a third secret that is cluster info properties that has information about my cluster, right? So everything that I want to provide is information that potentially others shouldn't see. I provide it as secrets, and also memory and memory reservation limit. Now, secrets are defined here, you see, and this is where volumes are defined. So in this case, you can use many drivers. There are like tens or hundreds of different drivers. In this case, I'm using Cloud Store. It comes out of the box with Docker for AWS. And by default, if you don't say anything, it works with EFS. So when this service is created, since it mounts this volume here, it will first create a volume. It will create an EFS drive. Then once the drive is available, it will attach it to this container. So to answer your question, never on the host, always network drive.
And this is mapped
By name, yes. So there is, it says here volume JM, and over there I referenced it by that name. Okay, and I have two, but the second one is not really important. And since I said here that is external false, that means that Docker stack will create it. It will not expect me to create that volume myself. Okay. So now first I need to create those secrets. So I'm going to say, okay, I'm going to use admin as a content of the secret called Jenkins user, and I'm going to use pass admin as secret called Jenkins pass. Let me load my credentials. Okay. And I'm going to create a third secret that has IP of my DNS of my cluster and my Docker Hub user, because I will need that. So now I can create the Jenkins stack with the master and the agent, and you can see here Docker stack deploy -c Jenkins YML, and it's called Jenkins, and a few environment variables, and Jenkins is up and running. No, actually, it will take a while because this service will first needs to create volume, and then only after volume network drive is created, it can create a service. And Jenkins is a bit monolithic, so it takes a bit of time for Jenkins itself to start as well. So let me show you Jenkins file just so that you see what will happen before it happens. So this is the repository of my project, of my service, GoDemo2. It has Jenkins file that defines everything. You cannot see that. You need to complain, guys. Defines everything that Jenkins should do on every single commit. And it says, OK, I want to run a function called Docker build that will build my Docker image. And you remember, build already has unit tests inside. I want to run my functional test. I didn't show you this, no time. And then if it comes from a master branch, then I want you to make a release. And if it comes from a master branch, I want you to switch to production and deploy it to production. And this deploy function not only will deploy to production, but it will also test the process before, during rolling updates, and after. And finally, Docker cleanup, which will clean up everything else. So, and those all, I can show you after this talk. I don't think I have time, but those are all, I can show you one, actually. Those are all very simple functions that, so you see, for example, Docker release just runs those commands that I showed you before. It says tag it, push it, and it's released. Same thing for the rest. Okay, where was I? How much time do I have? Oh, I'm going great. Okay, so let me open Jenkins. Let's see whether it's finished. You need to trust me that if Jenkins would die, the state would be preserved. It's still not finished. It is about to start running. There's a difference between using monolith services like Jenkins. It's just slow, and being Java does not help. Sure. I tend to automate everything, but first deployment of any given service I tend to do manually because first time I don't really know. I never did it in production. I want to be present as a human. So first time I deploy any service, I do it manually. And from there on, I have systems, we can speak about it later, that deploy new releases, scale it up, scale it down, add more servers to the cluster and all those things. So kind of humans, in my case, are only exist until commit and during first deployment of a service, kind of first release, in my case. Sorry. In my case, when I work with many different companies. So when I say in my case, when I work with companies that live in this century, I work with a lot of enterprises, and they are somewhere in 1999. So in that case, we kind of go with basics. This is what VM is. Let's move to 2000 somehow. Anyway, this is Jenkins. I can log in with, remember I provided username and password as secrets, so that's what I need to use to log in. There are a few, I think, things I need to do before this is fully operational. Yeah, I need to create Docker credentials so that I can push to Docker Hub. Admin, I said. Okay, so I'm going to add my Docker Hub username password as secret credentials. Called Docker, and I think that's all. Let me consult myself. Yeah. Okay, so let's see whether all this works. I'm going to go to Jenkins one more time, and I'm going to create what we call it Jenkins pipeline. Basically, it's a set of jobs that will communicate with the repository, use Jenkins file to find out what to do and do something. Whatever, and that something is whatever Jenkins file says. So I'm going to choose GitHub. The reason why it's so ugly is because I don't know why it's so ugly. Shitty resolution. I think it thinks that I'm on a mobile, and my internet connection doesn't help. Connection lost. Waiting. Please. Okay, so GitHub. Let me take my GitHub token. Okay, so I'm going to put the token here. So I'm going to say I'm going to use myself. I'm going to create a new pipeline. We said that we are all this time we're using Godemo 2 as the project. Create pipeline. Okay, and you see that there are 3 jobs. I'm going to stop those 2 because not to waste your time. It created 3 jobs because there are 3 branches in my repository, right? Feature 1, feature 2, and master. So master is what really matters. And it will start sometime soon. So now the process will run, and actually it will check out the code, build it, test it, test it, test it, test it, test it, test it, deploy to production, test again, make a release, and all those things, right? So you need to trust me this will work. I can move forward because I have only a few more minutes left. Yeah, the last thing. So now that you have the whole process, you still need to monitor your stuff, right? So I'm going to, no, I'm not gonna, because there's not enough time. But just go through the presentation yourself, and you will see how to monitor, collect metrics and all those things. And that means that while we're waiting for Jenkins to finish the job, you have like approximately 10 minutes for questions, 8 minutes for questions. No questions? You like asking while I'm talking to interrupt, no? But now when I say questions, nobody.
What's Docker stack? Is that kind of Docker Compose? Or?
No. So it's similar with Docker Compose in the sense that it uses same YAML format like Docker Compose with a few additional sections. Mainly the part in section deploy that's specific to stack. So it uses the same YAML file. It can use JSON as well, but it is part of Docker. So it's not Docker Compose or anything like that. Docker Compose works on a single server, single node, right? Docker Stack works with Orchestrator, in this case Swarm, that actually does things on a cluster level, right? And Docker Compose is scheduled to die. If you're using Docker Compose, rethink your strategy, because it's not gonna, slowly features of Docker Compose are moved somewhere else. Like Docker Stack is a substitute for Docker Compose run. No, for Docker Compose up, -d. Very similar, just applied to a cluster. Docker Compose is still useful for running tests and things that are where you need exit code from a container. But that will be also removed soon. It's not removed. Docker Compose will continue existing, but new and improved versions of it are moved somewhere else.
How do you provision the servers? Because you showed that you deployed all the Docker images into the 3 servers that you have.
Yeah.
How do you provision and how it's decided which image is deployed or running into which server?
Okay, that depends in my case from case to case. Okay, imagine that this worked. I need to check what was the fail. Doesn't matter. Anyway, so how I provision? Yeah, in this case, for today, I use something called Docker for AWS, which is a CloudFormation template, which uses AMIs with OS created by Docker for this purpose. So it's kind of busy box type of operating system with nothing but Docker server and stuff like that, and driver for volumes, which I showed you. If I don't use Docker for AWS, I would normally use Packer to create images and Terraform to instantiate all the services, including VMs based on those images.
Okay. Can you create new EC2 instances if you're using AWS via Docker also? Instead of using pre-existing ones?
Via Docker, not today. They're working on something called InfraKit, which will do similar what Docker does for containers for infrastructure. But now, today, if I would, in this demo, if I would have internet actually, it has 2 auto-scaling groups, one for managers, the other one for workers. So basically, when I want to scale up and down, I would just change the values of auto-scaling groups. And if I want to upgrade my OS, then I would execute rolling updates, which would create a new node with, let's say, newer version of Docker, connect it to the cluster, shut down the old node, create a new one. So it would kind of like create, shut down until the whole cluster is replaced, right? So to prevent any downtime. Does that answer your questions?
When deploy these in a development environment?
Same way.
Just exactly the same with
Ex-
the Docker stack?
I think that's the beauty of it. That I wanna have exactly the same process for any environment. Otherwise, we have those ridiculous situations. Say, okay, look, I do this on test environment and I do something else in production, and then I scratch my head why it doesn't work. It doesn't work because if you change anything, even a single line of something, even configuration file between testing and production, that means that you're not testing what you will be running in production. Right? So it needs to be exactly the same. Even on my laptop, I run I run Docker Swarm, a single node, still good enough, but this laptop is everybody has 16 gigas right now. You have a small data center in your laptop, right? So everything from laptop to any environment. Anybody else?
Did you, in one of the first slides, you showed some DynamoDB? Are you using that template used for the?
Yeah, DynamoDB has only single purpose in this case. It's there are some system level containers in this cluster on each node, and a node that becomes a manager stores that information. I'm a manager. This is my IP. Is DynamoDB.
Like an etcd or?
Yeah, like etcd, something like that. And the only reason why that is not needed for a cluster at all. But when a new node comes up, it needs to find out which node it should tell that wants to join the cluster. That's the only purpose. I think it's overkill using DynamoDB for something like that, but that's how they designed it.
How does the Docker Swarm keep the information of the cluster state?
Okay, so service discovery, equivalent of etcd, console, zookeeper, and those things is baked into Docker since last summer. So when every Docker engine that you declare to be a manager acts as service discovery as well. That's why I have 3 managers. You cannot have 2, split brain theory, and all those things. Anybody else? No? You have 1 minute, I think. I don't know. When does this end? Nobody knows. Okay, no questions. You're a shy public. Excellent. Or this was really terrible. Clever quote that makes me look clever. Twitter, tweet. Blog, what else? Courses, the YouTube, buy books. I'm going to destroy the stock. I don't want to waste more money on you guys than absolutely necessary. And there it goes. No more cluster.